Mathematics and classical modes of problem solving, for example, the scientific method, may not succeed in synthesizing meaning from the complexity and randomness that surrounds us. Complex systems and seemingly random systems may be best examined through aesthetic experience. We are surrounded and penetrated by ever-changing, invisible wireless communication signals that permeate our bodies at any moment. I seek to provide an interface that allows people to perceive and experience this complex and random system of electromagnetic waves. WAMS is a project that allows us to harness, interpret, and experience the wireless communication activity of a specific locale in a way that transcends the ability of our unassisted senses. The purpose of this project is to make apparent the characteristics, nuances, and overall excitement of the total spectrum of wireless communication in a specific place. These invisible characteristics are digitally processed and presented as visual and sound generations. An array of modified radio receivers pick up wireless signals from a variety of available frequencies. Normally, these analog and electric signals are directed into a speaker and converted into sound. I have disconnected the speaker from each device and instead direct the signal into a microcontroller, the Arduino decimal board. The Arduino is programmed to convert the analog electrical signal into digital information appropriate for computer processing. The digital information is sent via USB connection to an application written in the processing language, which is running on a MacBook Pro. In addition to radio waves, WAMS can also receive and process Wi-Fi signals. The MacBook Pro runs Carnivore PE, which is an open-source network monitoring software created by the Radical Software Group. Carnivore PE is used to intercept data packets from Wi-Fi networks. When Carnivore PE receives data from an available Wi-Fi connection, it sends the data to the processing application. The processing application synthesizes both the Wi-Fi data and the data from the radio receivers into sounds and graphics. In order to hear sounds that represent the stream of data from the radios and the Wi-Fi network, I use SuperCollider. SuperCollider is an environment and programming language that provides real-time audio synthesis. Each sound played by WAMS is created on the fly by SuperCollider using information from the wireless communications. All electromagnetic information that flows into the Arduino microcontroller is converted from an analog signal into a digital signal. The microcontroller maps input voltages between 0 and 5 volts into integer values between 0 and 1023. Voltages close to 0 will output numbers close to 0, and voltages close to 5 volts will output numbers closer to 1023. The integer values are sent via USB to the processing application on the MacBook Pro. The values from 0 through 1023 are used to set the frequency or pitch of the sound that we hear. High voltage values result in higher pitched sounds, and lower voltage values result in lower pitched sounds. In addition to sounds, integers produced by the microcontroller affect the size and color of the graphics. Low voltages translate into smaller bursts, and higher voltages into larger bursts. The hue of the graphics follow a gradient from red to blue to green. Red corresponds to lower voltages, and green to higher voltages. Here are some examples of the relationship between the voltage that has been converted into digital information and the sounds and graphics that are displayed. The color for each burst that represents Wi-Fi traffic is calculated by using the first 3 octets of the IP address from the sender of the unit of data being examined. The numbers from each of the first, second, and third octet of the IP address are used as the red, green, and blue color values for the graphic. The size of the graphic and the pitch of the sound that is played are determined by the size of the data packet that is being examined. This is the final appearance and sound of the graphic generated by a packet of data that is 926 bytes received from IP address 205.188.100.136. By mapping a sampling of wireless communication into sounds and graphics, I hope to create a representation of the complex and seemingly random system of wireless communications that is perceptible by human senses, that may aid in synthesizing meaning about our world.